Okay, so guys, welcome to the second part of Lanthanides and Actinides video series. Uh, so coming to the source and extraction of lanthanides and actinides. So monazite. So monazite sand is an important and widespread, most important and widespread mineral. Okay, so it accounts for up to 78% of lanthanides. It's a mixture containing mostly titanium phosphate and trivalent of lighter lanthanides such as cerium, priya and neodymium. Okay. Uh, okay. So it also accounts for smaller amounts of yttrium and the heavier lanthanides and thorium phosphate. Uh, so what is specialty of thorium? Thorium is an actinide. Thorium is radioactive, which means its daughter nucleus, which happens to be isotopes of thallium, lead, bismuth, polonium, radon, radium, and a whole lot of this actinium are also part of this monazite ore because this contains thorium phosphate. Okay. Next is bastionite. Bastosite is a mixed fluorocarbonate. Okay, bastionite is another ore. Xenotime is another ore. So this was about your source of lanthanides. Okay. Now coming to the size of lanthanides, very important. डायरेक्ट क्वेश्चंस आ जाता है इधर से. Size of lanthanides. So what happens when you go down the row? Size increases or decreases? Size increases, that is both ionic and covalent radii increase because principal quantum number increases. Everybody knows this. Now as you go from left to right, okay, top to bottom, what happens? Size increases. Okay. Now when you go from left to right, what are you doing? You are adding one electron, proton, neutron, whatever. Okay. You are adding. So, but what will happen to the size? Everybody knows this. There is no secret. कुछ भी नहीं है. Size decreases. भाई क्यों? You are adding one more electron. You are adding more proton, which means size should increase, right? Why is the size decreasing as you go from left to right? Very simple logic. Because Coulombic force of attraction is not an independent effect. Okay, it is a combined effect, which means it's a cluster of protons acting on one molecule. There are a lot of nuclei, there are cluster of protons. So these cluster of protons are acting on each electron. Now what is this? This is a positive charge. हमें क्या पता है? So why does size decrease? So let us go to this. Now opposite charges attract and like charges repel. Okay, so now let us put this into perspective. There is a positively charged nucleus, okay, and then there are electrons here, then there are electrons here, and then there are electrons here, and also there is electron which is outermost shell. Now what is happening is this nuclei, which is a number of positively charged protons, obviously like charges attract, so this will have a very strong attractive pull, which means if this is pulled, what will happen to the size? Size will also decrease, right? But again there is another thing, that there is similarly charged, which is negatively charged electron here, and that will also try to repel. So there's attraction here and there is repulsion here. Okay, so while this electron is trying to get attracted to this, is pulled towards this, there are electrons which will try to push it away, repel it away, which means, so this is what we call it as shielding effect, right? So shielding effect will keep the electrons at bay, which means size does not decrease rapidly, okay, because of this shielding effect. So shielding effect is the reduction take down if you want to. Shielding effect is the reduction in the effect of nuclear charge on the electron electron cloud in question due to the repulsive force electrons on the electron in question. Okay. The point here is this everybody knows. Okay. Now, what is that you need to know? New thing here is the shielding effect of electrons decreases in the order. So s orbitals greater than p orbitals greater than d orbitals and greater than f orbitals. Okay, the reason being the shape of the orbitals. What is the reason? Reason simple का है, simple सा है, shape of orbitals. Now consider s orbital. S orbital के लिए very important, pay attention. Okay guys, whatever you are doing right now, don't do multitasking. This 3 minutes you give to me, then you'll understand the whole concept here. Okay, now this is your s orbital. This is your nuclei. Now there is a outermost electron here. See, because it is spherical in shape, what will happen? There is an effective repulsion that can take place. Now consider that this is for s orbital. Now consider for p orbital. Now consider the same thing, the same electron being here. See, what happens is for an p orbital, this is directional in nature. Okay, so which means this outside ka electron will not be able to repel this electron to the extent to which s electron could have repelled. If this is an s electron, we put it, okay. Okay, this electron could have, this electron is better at repelling this electron, but look at this. This has already, it is way beyond here. Okay, so it cannot repel to that extent like a s orbital. The same goes with d orbitals, because d orbital is even more diffuse. Imagine the same electron that is here and your d electron is here, so which means it's even more diffuse. It can be here, it can be here, it can be here, it can be here. So again, its repulsion will decrease. So in ineffective screening of f orbitals, and this was for d orbitals. Now if you come to f orbitals, f orbitals are even more spread out. Okay, So this is what we call as concerning f orbitals and the electron. As you know, it shielding effect decreases now sp d f are f orbitals are very poor at shielding. So this is what in chemistry language we call it as ineffective means electrons are pulled even closer. Okay, so therefore size decreases. Fine. So there is again a small piece of information that you need to know. So just I'll come back to this thing again. So let me just add another slide. Okay, yes. Now P, Px, Py, Pz, D में dx, y, dxz and dyz. So these are the subshells, right? D x square minus y square, and actually everybody knows it as dz square. Okay, but the truth is it has been abbreviated as dz square, but you should know that it is d2z square minus x square minus y square. If you go to the quantum chemistry, this is how the source is Huey. If you want, you can cross check. So fx cube, fy cube, fz cube, 3 orbitals, fz, x square minus y square, fy, z square minus x square, fx, z square minus y square, and the last one f x y z. So these are the f orbitals which are very poor at shielding effect. Fine. So in case of lanthanides, lanthanides में क्या हुआ? And what are ultimate orbital is 6s, penultimate is 5d, and anti-penultimate is 4f. What did I do? क्या किया भाई हमने? Okay, just wait. If I zoom, no, I'll get. Okay, it is here. Fine. How are okay? So ultimate is 6s, penultimate is 5d, anti-penultimate is 4f. Okay, so now because these are inside orbitals and these are very poor at screening the ultimate electrons, the outside electrons, so what will happen is take down very important increased nuclear charge plus ineffective poor screening 4f levels. What will happen is electrons are pulled, closer, size decreases. इसी के लिए we'll tell there is a chemistry word for that. It's called lanthanide contraction. So lanthanide contraction is a steady decrease in size along the series of elements La to lutein. Okay, simple sa concept, very important in understanding the chemistry of lanthanides and actinides. So shall we close here? So this is the second part. Stay tuned for the third part. Don't keep a lot of things pending. Every day listen for 20 minutes and your exam is on 26th. Okay, even if you listen every day 26 minutes, still you can complete the syllabus. It's doable, guys. Okay, so thank you again. Stay tuned. Bye bye.